I just opened up the webinar to the attendees, so maybe we'll give a minute or two for people to flow in. To everyone who's joining in on this webinar, we'll be starting in a minute or so. I think the attendees list is still loading and a lot of people are joining it now.
Yeah, the other thing we might do is encourage people to use the Q&A area. There often isn't enough time for all the questions, but if they can put them in the Q&A, then we can use that to help document the event and do some circulation.
I'll be sure to mention that.
Yeah.
We'll go ahead and get started. Thank you to everyone for joining in this webinar. This is the first webinar that Gabby is hosting in 2022, and we're really excited to get this started. We've got two amazing speakers with us today, Milt Caplan and Andy Paterson. Today's topic will be on the cooperative opportunities in the global SMR arena. And to begin this webinar, we'll have Milt begin with a short introduction. And then we'll follow up with Andy's discussion. Milt, do you want to go ahead and start with the presentation?
I do. Good morning, everybody, and thank you for listening this morning. And if there's anybody listening from Korea and other such places, I appreciate you taking time during your holiday week, and I wish you all a very happy Year of the Tiger. I'm just going to take a few minutes here. Hang on. Can you see my slides yet, Brian?
Yep, we can see the slides.
Yeah, so I'm going to just have a few slides to go over some of the things I've talked about before and talk about, what's been happening in SMR deployment and why 2021 was a really good year and why ongoing collaboration is important to see SMR success. Okay, sorry, it's a little bit slow here. Yeah, so just to remind you what is an SMR, because we may as well start off with the definition. And so remember, SMRs are exactly what they sound like. They're small and they're modular. So generally, we tend to talk about size two categories of SMRs, sort of the grid scale SMRs that are sort of the 300 megawatts and just under. And then we have the micro reactors, which are sort of the off-grid SMRs that are sort of maybe 5, 10, 15, 20 megawatts. But let's remember that the objective of going with SMRs is to reduce the risks of delay and cost overruns of very large projects by deploying them more quickly and at lower total cost than doing sort of these massive big projects. But the other important objective is that for SMRs to really make a difference in decarbonizing the world, it's important that we expand the market to a broader customer base who can benefit from these kinds of solutions. So it's not about necessarily replacing large reactors, it's about complementing them and having a broader customer base of people that would never imagine, building a 1,000 or 1,200 or 1,400 megawatt project or, spending 10 or 15 billion dollars on a single project. It would just be beyond them. Now, the other thing to remember, though, is SMRs are indeed a little bit different. Whoops, sorry about that. Getting a spam call while we're... And SMRs are really trying to overcome the economies of scale in nuclear based on the economies of numbers, modularity, and standardization. And that's important because, the economies of scale are real. I mean, there's no doubt that the bigger we make plants, the more economic they become. And we often forget one of the reasons we make nuclear plants so large is because we can. You know, the high energy intensity allows you to make plants that are very, very large. So SMRs are trying to do the opposite. They're trying to say, let's take advantage of the economies of numbers and modularity and standardization. And that means you need a fleet approach that would see SMR designs built in factories, promoting standardization and learning by doing through the building of subsequent identical units. And one thing that's different when it comes especially to the policy side and the political side, it's important to understand that rationalization of factory build and global supply chain puts the focus on costs, not local content, right? So, you know, now when you think about conventional nuclear, those are massively big projects. You're always talking about how many jobs it creates locally, how much it impacts the economy. This is not the case for SMRs. The idea is to actually have most of it built by the same supply chain and sent to the locations where it's going to be implemented. And the benefit that comes from it is low cost. And there are many different options, many different types of SMRs still in the development phase, from more traditional light water reactors to more advanced reactors that offer higher temperature solutions. There's all different kinds, and that's not really the issue that we're going to talk about here in terms of which technology. Now, I want to point out that 2021 was a good year for first-of-a-kind SMRs, because let's face it, one of the important things we've talked about in the past year was, you know, if we're going to have an impact, we got to get going, right? We got to see some demonstration plants built of these newer or updated technologies so we can get ready to move. And so if we look at some of the, most of the first-of-a-kind development has really been in the UK, in the US, and here in Canada, where I am. So in the UK, for example, Rolls-Royce has been restructuring and getting a large amount of financing ready to go. They've just recently come out with a request to find a site for their factory. In the US, you're all very much aware of the ARDP program, where money's been allocated for two projects, first-of-a-kind projects, one with TerraPower, which was going to be deployed in Wyoming right now, and one for X-Energy, which is intended to be deployed in Washington State, as well as a whole variety of other awards of money to people to develop their technologies. But again, I'm focusing here on demonstrating that it's these first-of-a-kind demonstration plants that are really getting going. We've seen NuScale, you know, the first company to sort of do a reverse takeover and become public, and, you know, with a large valuation. And then I think just yesterday we saw an announcement of significant progress at the site to prepare the site to get ready for deployment. We can't go without speaking about what's happened in China, because their pebble bed gas-cooled reactor actually went into service late last year. And that's a big milestone, right? So it's important to understand, you know, people are doing things. Now for the projects that are sort of more near and dear to me, because I'm Canadian, there's been a lot going on in Canada. So we have what we call a three-stream approach, where we're looking at sort of reactors that can be deployed quickly for on-grid, Gen 4 reactors that may take a little more time, and also microreactors. So Canada's first microreactor demonstration project, Global First Power, is being deployed at Chalk River, and they're well into the licensing process now. So that's very important milestones. For the Generation 4 designs that are being developed in the province of New Brunswick, they've received both federal and provincial money, both for ARC and Moltex to develop their projects. And there's a lot of work going on to keep those projects, get those projects going. And I think the one of most interest to people that people have heard a lot of noise about in the last little while is that here in Ontario Power Generation, after going through a selection process, chose the BWRX 300 for the Darlington new build. And let me focus on this for a minute. Why is this project important, and why do I think what we're doing here in Canada is important? In addition to what's going on elsewhere in the world, one of the things we've done here in Canada is we've had a lot of collaboration between the various levels of government. So we started off with a federally led SMR roadmap, followed up by an SMR action plan. And then because electricity generation is a provincial jurisdiction in Canada, back in 2019, 3 of the provinces signed a memorandum of understanding to collaborate. And last year, Alberta became the 4th to join. The other 3 are Ontario, New Brunswick, and Saskatchewan. And so even though we're looking at a variety of different things, it's all about collaborating. And what that collaboration does, it allows everybody to work together to address the same issues and try and ensure that policy is put in place that will help support the program. The other thing that's important with OPG's project is that what we have here is a real qualified, capable nuclear utility, in addition to a capable vendor, technology developer who can help make the project successful. Because not only is OPG a capable world-class nuclear operator, they're also in the midst of a life extension project at their Darlington nuclear plant, which they're now about halfway through, and it's on time and on budget. So they also have very real, relevant, and recent project management experience about how to make projects successful. So this will help to drive this project to a successful completion. But again, as we say, committing first of a kind SMRs is a critical step, but it's only the beginning, right? Because for SMRs to make a difference in the world, what's important is that you have a lot of them. And what's important for them to be economic is that you have a lot of them being done in a coordinated way. And so, yes, what this first of a kind demonstration plant will do in all these jurisdictions, it will demonstrate the plant's licensability, it will demonstrate the capability of the supply chain, it will demonstrate the capability to deliver the design, but it will also demonstrate the project credentials, the project management, the operability, and of most importance, it will demonstrate the economics and the business model, although we have to accept that the first of a kind plant will be more costly than future plants. So what does that mean? This is a challenge, right? Because while the focus has to be on getting that first plant going and making sure it's successful, at the same time, the teams have to work to start deploying the fleet. Just think about sort of an aircraft analogy. If Boeing or Airbus develops a new aircraft, they build one and test it and prove that it works. But before they really get going, they want to have so many orders in the order book to know that they're going to have an economic program. And so what we need to do now is figure out how to scale and develop these fleets. And that means you have to be out there working to develop the first set of fleet deployment customers, right? Because what you have to do is you have to work together with these folks to help them to prepare for their new programs. Just assume some of these places don't have nuclear in those countries. They still need to develop their regulatory process. They need to develop the capability. They need to develop how they're going to move forward without spending a huge amount of money to get to the point of beginning. The other thing is, as we develop the capability to build the first of a kind, you have to have an understanding of how you're going to develop the global capacity to deliver on the fleet, both with human capital, whoops, I see a typo, sorry about that, and supply chain, right? So it's when you go and to a specific company and say, well, we want you to build component A, it's not enough to say, well, give me a price for component A. You also have to be able to go to that company and say, and our plan is, based on what we see now, we're going to order not one of those components, but 15 of them in the next 10 years. So what do you need to do to scale your manufacturing capability to meet that need? And we shouldn't underestimate the importance of developing the human capital, right? Because you have to make sure that people have an opportunity to learn from what's going on and then move forward into new projects, but also make sure that the existing projects get finished. We also need to develop business models to enable rapid deployment. And governments always have to be engaged because, let's face it, nuclear technology is export controlled and governments and agreements need to be in place. So it's nice to talk about exporting to a given country, but if there's not a 1, 2, 3 agreement in place, then somebody has to do that. Or in Canada, the equivalent is called a nuclear cooperation.
Just quickly, Milt, on that previous slide and the OPG project, which everybody's following, can you comment qualitatively at all about the elements of the financing in that? How much provincial, not how much, but is there mostly provincial capital, no federal capital?
I think it's not fully decided yet, but what has been decided is OPG is a rate regulated utility, and this project will be rate regulated. So that's the model. When we get to the fleet, it's just, I've used this slide before. It's like we have to remember what you need to say is, okay, here's the first set of customers, whether it's, 5 of them or 8 of them, and some are going to build a single unit, some are going to build 2 or 3 or 4, but you got to get them to work together so they can learn from each other's experience. Because one of the areas of costs that people don't talk about is how much it costs to get ready. One of the strengths, which I forgot to mention, Andy, is at OPG is they're one of the few places in the world right now that actually has a licensed site ready to go. And, so while they will have additional costs related to first of a kind deployment, they do save from today because, it takes time and money and effort to develop a site, choose a site, go through an environmental assessment, et cetera, for others. And so that's a very valuable resource. And again, the first group of players will be the one that if they want to get some, economic benefits, they're the ones at the beginning who can say, well, let's distribute some of the supply. Maybe all of the valves will come from country 3's customer because they have a good valve supplier, and all of X component or all of Y component. So it's about figuring out how to best work together to be efficient. So just to summarize these opening remarks, SMRs are every day seeming to be a more and more viable option for future electricity generation that's low carbon, reliable, and economic. But always remember, success is predicated on deploying fleets to reduce both cost and risk. Market development is required to drive SMR new build. I mean, we have seen a lot of folks going around the world signing various MOUs, but again, that's a first step. There's a lot of work to get to really developing projects. And I still strongly think that potential customers should work together to collaborate on SMR deployment to help reduce their costs and risks as soon as the first of a kind projects are committed. And I'll stop there and pass it over to Andy. Thank you so much.
Thank you so much for those remarks, Milt. Canada is definitely on the leading forefront of the SMRs, and I really want to circle back to the licensing and market development, but first I'd like to invite Andy to speak on the global market, and let me pull up the PowerPoint.
Sure. Well, again, thanks to Gabby for organizing this very, very timely topic. For those of you that have not met Milt Caplan, please take this as an opportunity to interact with him. He's one of the most well-aware people in the nuclear sector in Canada that I've ever met. And this goes back 20 years, I think, almost now, with the World Nuclear Symposium. We were both panelists in 2003 in London. So I've long held a great admiration for Milt's work. And I think now, Milt, your perspective is even more valuable given the inflection point that I think you outlined for SMRs. I think this is going to be a non-linear break from the past as we move into the smaller formats. What I want to do is pick up on some themes that Milt highlighted and talk about global drivers for SMRs that I think are going to create opportunities for cooperation, which is the main theme that Gabby continues to highlight. Let's go to the next slide there, Brian. So our perspective at EBI as part of the Allied Nuclear Partners Initiative led by IP3 is really to pay attention to what's going on in the landscape in both policy and in what we call the nuclear SMR arena, where, as Milt hinted, there is as much government involvement, particularly the likes of Russia and China and France, as there is private industry, trying to develop new designs of SMRs. So that has to be called out whenever you're talking about the nuclear arena. And Milt, I tend to call it an arena rather than a market because of the heavy government involvement, not only in licensing, but actually in selling reactors in the case of Russia and China and France. So it's an arena, and it has been an arena for gladiators, nation state gladiators in the case of Rosatom and CGN and EDF. So in that respect, people need to bring a third dimension to understanding how the game board is unfolding here, and I'll say more about that. So what I think is interesting, and I would welcome Milt's comments, and any of you that have access to the Q&A box, please start typing questions in there for two reasons. One, Milt and I can monitor those, and two, Brian and company will gather some of the Q&A, and when we report out back to you, we can respond to some of the questions in the Q&A chat box. So let's get that going. One of the things that I thought was really interesting, and Canada has been very progressive, Milt, more so than here, on the whole climate change and COP26 issue. We were watching this closely, and it's my opinion that the anti-nuclear crowd utterly failed in COP26. In fact, a lot of the climate scientists like Jim Hansen and others have asserted that nuclear is essential. So I want to put that theme out there. The second point I would make as a major driver is in the Northern Hemisphere developed economies, there's not as much awareness of the fact that there's going to be 3 billion more people in cities by 2050, starting in 2010. And this is a doubling of urban population. It's a massive global driver. The civilization has never, ever witnessed this volume of urbanization. So I believe that nuclear, not so much only because of the low emission profile, but the compactness. And I think, Milt, this doesn't get talked about enough, that the land use of solar and wind is 200 and 400 times per kilowatt hour over nuclear. And so you go elsewhere in the world and land use becomes a larger factor than just cost of electricity. And so as the population becomes more and more urban, land use becomes more and more important is one of the predictions I would make. In fact, what we observe is that wind and solar really are not the sources that you want powering cities. Use them as much as you can, wind and solar and biomass and hydro. But, I get into arguments with my millennial kids about climate change and nuclear. And I ask them, with more and more climate change, why would you place more and more of your energy supply on weather? There's going to be more severe disruptions, as we're already seeing, whether it be the water cycle or extreme storm shifts and those kinds of things. Why would you place more and more of your energy supply, your critical energy supply for cities and mass transit, based on weather? This is some form of insanity. Likewise, what we're seeing already, Milt, is that there's a surge now in the heavy industrial sectors. You might be seeing this in Canada as well, where they want SMRs to be dedicated to providing not only power, but heat. And so I submit that the advanced designs for the reactors that offer a 600 C outlet temperature versus the light water reactors with the 300 C are going to be adopted sooner than some of the technical forecasts. And the driver is going to be industrial. And so I'll get into a little bit of that. So what we're seeing when we talk to the finance community is that the way that they're looking at nuclear is shifting now away from lowest cost of electricity toward value. and security at a number of levels: energy security, national security, and now food security, with a lot of fertilizer plants being shut down. So I'll talk a little bit about that. And so both forms of SMRs, the light water reactor that OPG ordered, the GEBWR and the LWRs, plus now the new advanced modular reactor designs, are going to be absorbed at a faster and faster rate. So the reason I highlight this for this seminar, Brian and folks from Gabby, Florence, is because Korea offers us a terrific partner in that kind of a landscape, where nuclear is going to broaden its application out to chemicals, metals like steel forging, cement, the making of hydrogen, the coming of the hydrogen economy, and now fertilizer, which is a GHG monster if you make it from methane. So in the heavy industry sector, Korea is already at the forefront of a lot of these industrial sectors. Fuel cells is another example, electric buses. You know, Korea is a leader globally in a lot of these niches. So that's going to be important to focus on going forward. Tap it one more time if you could, Brian. Yeah, so what are the challenges in this kind of a landscape? These are kind of opening themes. Well, China and Russia, as we've seen, Milt mentioned it a little bit, are taking large shares in the nuclear energy arena with their state-backed companies, Rosatom and CGN. And so for China and Russia, nuclear is not an LCOE exercise. It's a weapon that they use in foreign policy. They use nuclear power projects in Pakistan, in India, in the Middle East, in Turkey, to take territory. It's an arm of their foreign policy. It's not just an LCOE conversation. What we've seen also is that the large reactors, whether it's at Vogtle or Flamanville or over in TVO in Finland, we're watching Hinkley Point now, are overrunning their budgets. I think orders are going to be muted in the large reactor sector as more and more SMRs come along. And I think Milt did a great job of outlining the value proposition and the reduction of risk that you get by manufacturing reactors instead of building them on site. And so what I would say to the US folks is that the traditional lens through which we view nuclear power with our fleet of 96 gigawatts, which is now being extended, much of it will be extended for 20 years, is a very, very distorted lens through which to view the unfolding of the nuclear arena. So what you see in the US market does not give you insight as to what's going on in the rest of the world. And so that's what I wanted to flag early on here, is the global perspective that's needed on this SMR arena. Next. So this is the forecast IAEA put out at their last general conference. They usually do a high and a low. And so the high forecast, and this is under the scenario that we're already starting to see with higher gas prices, is back up to 790 gigawatts or so. And they're maintaining their low forecast at 394 gigawatts. And this is capacity in 2050, not construction. It's how much capacity is going to exist. So even in the case of the low forecast, with at least 200 gigawatts being retired, you can see in the low forecast that more capacity is going to be added. So then we ask the question, well, what portion of this forecast could be advanced reactors and SMRs? And we submit it could be quite significant. Tap it one more time, Brian. And then we're starting to ask a new question, which is outside of the power sector, like the heavy industrial sectors I mentioned. How many more, high temperature AMRs could be deployed, increasing the capacity above 1,000 gigawatts by 2050? So we think that's an increasing trend, and we're at an inflection point. Next. Yeah, so I highlighted that even in the low case, you're going to have to build reactors. I mentioned this. This is the huge urban driver in graphical form. 3 billion more people in cities by 2050. And you can see there the small circles in white on the larger map, how they're so highly concentrated in the developing countries. Next slide. Yeah, so just to take a picture, put it in pictures instead of words. This is kind of the situation when you go to some of the other places in the world. I mean, India, Bangladesh, Seoul, you know, the evening commute. San Francisco, I was traumatized when I went back to my 40-year college reunions, as I'm from the Bay Area. You know, in wildfire ash. Some of it due to running these transmission lines all over the place for gathering wind power. And so these urban demand profiles where you don't have as much space to put down solar panels and wind turbines are going to push more and more decision-making toward SMRs, we think. Next. Here's what's going on with global emissions. What became apparent, at least to me, out of COP26 is we're not on a trajectory to reduce our emissions. A lot of that is China, I accept that. But we just performed a global experiment of shutting down our economies with the pandemic and with the shutdowns. And it didn't save much. In other words, you can't conserve your way to meeting the climate change objectives of 2 degrees C. You have to replace fossil fuels. And so in our view, over the next 30 years, that's increasingly going to be nuclear. Next. So here are the forecasts from Paris. If we could tap it one more time. I thought James Hansen made a very, very interesting statement in Paris and reinforced it in Glasgow, which is there's no credible path to climate stabilization that does not include a substantial role for nuclear power. So he is calling out the renewable only campaign by Sierra Club and Friends of the Earth and whatnot as interfering with our ability to reach the climate objectives. So I put that forward to the renewables only advocates. And then secondly, Brian, if you could tap it. So Dr. Ernie Moniz, when he was working at MIT, PhD in applied mathematics from Stanford, did some math also. And his conclusion was we can't get there with renewables only. So lots of very smart people have really done the math on how we get there on carbon emissions. And you have to have nuclear as a significant portion, not just at the table, as a significant part of the solution on emissions globally, particularly as demand is rising in the developing countries. And SMRs are going to be key to that. Next. So one of the things that doesn't get talked about enough, in my opinion, is the water cycle versus air in climate change. And I believe that the water cycle is actually where we're going to see the most impact with climate change. And so you can see here with the projected water stress in 10 years that, tap it one more time, that at least half of the global population, which will be 8 billion by then, will face water stress. And so to the degree we could look, Milt, at SMRs for desalination, that is going to become another essential niche going forward for the next 30 years, particularly since 60% of the world's population is near the coast. And in terms of cooperation, Florence, with Korea, in the case of Hyundai and Doosan, have built some of the largest desal plants in the world. I think the one in Saudi Arabia is built by the Koreans. So again, here's another example in a major sector where there are some big shifts, where Korea is also a leader in terms of desalination. Next. Yeah, so I highlighted this point here with the big cities, you know, Seoul, Korea during a snowstorm, the London blackout in August of 2019, Chicago in winter with their elevated train. The land use issue, I predict, is going to become more and more important as more population migrates to cities. So you'll have these slides, and I think Brian and Florence will send them out. This is a very, very important issue that doesn't get talked about enough. Next.
Andy, I was hoping if we can keep this the next 5 minutes wrap up.
Yeah,
possible.
no problem. Okay.
Okay, thank you.
Yeah, so then this was my point about weather stress and how renewables are not adequate to dealing with ice storms. And, even the case of Michigan, they had a gas compressor blowout. So there are a lot of situations where nuclear is the go-to fuel choice, and it's not based on LCOE. It's based on durability and ability to stand up to the stresses in weather. Next. And when you've got wind blades snapping off in Michigan. So this is the current market share, and the United States needs to understand how little market share that the US has. And really, Korea is a significant player there in light purple. And then you see, as I've referred to previously, Russia and China occupying huge swaths of the nuclear market or arena better. That's currently under construction now, 53 gigawatts. Next. And so we're just not up to par. We're going to need Korea as a partner. Next. Yeah, so this is another more dramatic way to show where the construction is actually occurring. And you see again, China and Russia. This is a graph that shows where they're being built and who's building them. So tap it through and go to the next slide. You'll see this when we send it out. This is a larger collection of projects underway now. And this is how they're being organized. So this is part of my thesis that it's an arena, not a market. You can see the dominance there of national owner, national vendor, national owner, internally built, not even taking a bid now in Russia, China. And then the other subsidiary kinds of deals that get nuclear done. These are the larger deals. I think what's going to be interesting with SMRs is you're going to have industrial customers buying the reactors. Next. These are the SMR projects, Milt, that we put together. So all of the deals you mentioned are in this rack up. And again, you'll get the slides. But our point here was that now the SMR deals that have sites that are virtually through licensing or almost, and that are talking to financiers, it totals more than 50 billion. It's nearing 10 gigawatts. Right now, it's 46 reactors in 20 projects. And again, all the projects you listed are on this list. So now I think we're at a point where we're seeing critical mass in SMR projects. It's not just a bunch of scattered cats. Next. Milt mentioned aircraft, and I want to highlight the industrial experience with the Boeing 777, because we can do this. We can manufacture SMRs just the way we did aircraft. And so this was the industrial profile for the 777. You can see the orders and the deliveries. That was a concept that Milt highlighted in terms of building the fleet. Building the fleet is going to be the way to approach SMRs. Next. And likewise, electric vehicle as a demand pull on the charging side, and you're not going to charge electric vehicles at night with solar. Solar and wind are not going to be reliable in terms of charging electric vehicles in urban areas going forward. Nuclear is going to be the mainstay, in my humble opinion, by 2040. Next. Yeah, and so the other main theme I want to close on, Brian, is that the advanced reactors, the advanced modular reactors with the higher temperatures, get you into a variety of energy intensive sectors now, where a lot of the GHG emissions need to be dealt with. And it isn't going to be handled by wind and solar. You cannot do a lot of these industrial processes with both heat and power needs through wind and solar. So I submit nuclear SMRs are going to be the mode going forward. Next. And so what we're seeing in Europe now is going to be, I predict, I would like to get Milt's take on this. Europe with a 70 euro per ton of CO2 tax, the carbon border adjustment mechanism, and now painfully spiking natural gas prices. Industry, from what we're seeing, is scrambling toward SMRs. Otherwise, they're going to lose their factories. It's already happened in the fertilizer sector, where a lot of fertilizer plants have been suspended now in Europe. And so Europe is going to be, and their nuclear units are older, so they're not renewing as many of them. So those big drivers are offering a completely different arena than what we see in North America. Next. Yeah, so this, I'll close with this, Brian. So I dramatize this because this slide is only possible with SMRs. None of these industrial sectors are going to go out and buy a 1,000 gigawatt large nuclear reactor. They'll buy a 100 megawatt SMR. They'll buy several of those. They have different factories. But now you can start to see the niches where heavy industry needs heat and power. This is not an LCOE, lowest cost of electricity decision. They need the compact land print. They need the always on heat and power of an SMR, and they're going to buy fleets of them. Chemicals, green hydrogen, ammonia, desal, aluminum, and metalworking. Tap it one more time. I want to close with the areas of cooperation. If you note here, Korea as a partner is already a global leader in these niches. They're an ideal partner situated at the center of where a lot of this is unfolding. And so the United States, I submit, needs to wake up to a cooperation opportunity with Korea for industrial deployment of SMRs. Look beyond the power sector. Industry, I submit, Milt, is going to be the first adopter for a lot of these fleets of SMRs, the AMRs and the light water design. So let me pause there and we can turn to some questions.
Thank you, Andy. Very comprehensive and yet detailed overview of the global arena. As we mentioned earlier, there's a Q&A box at the bottom. Please feel free to submit your questions. I see we have a number of questions already. I will, as the moderator, begin with some prepared moderator questions before we go into the audience Q&A. Milt, I kind of wanted to circle back, and the first couple of questions might be a little more geared towards you. In the US, we seem to have a bit of a political polarization on decarbonization, yet nuclear energy is receiving significant bipartisan support. Could you possibly share Canada's experience with nuclear energy and what is driving the conversation there? Is it climate change, energy security, or something else?
Sure, and again, as is in the US, Canada's not one, ubiquitous country. It's different in different regions. In Canada, you have to remember that we're basically a hydro country. We don't call electricity, we call it hydro. You pay the hydro bills, the hydro lines fall. We're very, very focused on hydro because we're very blessed. But here in the province of Ontario, which is our most populous province, nuclear has been the workhorse for 30 years. Nuclear produces around 60 to 65% of our electricity on average. So, it's well established. There's not a lot of opposition in places like Ontario, or even in New Brunswick, where they have a single unit, but it's a small province, but it still represents a third of their generation. So there are small vocal sort of anti-nuclear groups, but I think in general, people are supportive where we have it. It's going to be interesting to see the challenge as we try and expand it to non-nuclear jurisdictions like Saskatchewan and Alberta, which are, fossil provinces. They're very focused on getting off coal by moving to gas in the first instance. But that's where targets of net zero change everything. And I think it changes it for the United States as well, if you get to accepting those targets. Because, you know, if you're a fossil heavy system, it's very easy to say, well, you know, we'll build as much wind and solar as we can, and we'll burn less fuel. And that works until it stops. There's some natural level where, you know, it just stops reducing the amount of fuel you burn. Now, if you're told, well, it's not about reducing emissions, it's about saying at some point in the future, you're not going to be allowed to burn fossil fuels anymore, or at least not if there's not carbon capture. That's a very different problem to solve, right? So, you know, the type of stuff Andy talked about, as you get to saying, you know, and what's caused the slow growth in nuclear, I would say, in most of the industrialized world in the last number of years, has been the low growth in electricity demand, right? You know, when electricity is growing at 1% per year, you know, and gas is cheap, nobody's thinking we need to build these massively big new plants. But if now you're saying you have to electrify everything as part of your, you know, decarbonization model, you know, most models say it means, and depending on the jurisdiction, there could be a doubling of the electricity system, and you got to do it low carbon. You got to look at different ways of doing that. So nuclear is getting a lot more attention. But like I said, I don't think we've ever had, and I think I see it in America as well, and even in parts of Europe. I think we're seeing a lot more support for nuclear. It's usually supported in the places where it's needed. You know, it's opposed by groups where they either it's not that needed or people think it's not needed, which is not always the same. So I'll leave it at that.
Let's see.
On that, Milt, can
yeah.
you comment? One of the questions that came up, Milt, was on hydro. Wouldn't the impact of urbanization and water stress also be a detractor for hydropower and another argument for SMRs? I think so. In the United States, we haven't built new hydro capacity in 50 years. Well,
it depends, right? Because even in Canada, with our vast hydro resources, most of the large hydro sites are now used up. You know, Quebec has been damming the far north, and it worked for them, right? They found a way to say we're going to build all our generation way in the north and have, you know, these really long transmission lines. And for a while there was a struggle. You know, I remember there were days in the French newspapers there, you know, they'd have today's outages because the system had become a bit unstable. But now you have, you know, Muskrat Falls in Newfoundland coming near completion. You have the struggles you see with the Site C Dam in British Columbia. And even there, you know, the recognition is once Site C gets completed, if all of a sudden they have to grow their system because they want to electrify everything, you know, the days of having a lot more of those massive hydro sites are behind us. That doesn't mean, though, there won't be a lot of smaller hydro projects or run-of-river projects. It depends on the robustness of the system, right? If you have a robust grid, the key is that if they're sizable, that's different than having a widely distributed grid, which you have with renewables, where you have sort of many inputs and many connections scattered over very large land areas. But I think the benefit of hydro is still that it's dispatchable, and so it's still different than, you know, when you show that picture of Seoul or Dhaka, you know, it's nice to imagine, you know, living in California and having solar panels on your roof and having a garden where you grow your own food. Tell that to one of those folks living in one of those high rises, you know, cramped in with, you know, 3 generations of family members, that, yeah, you should put a solar panel on. The solar panel on the roof is going to produce all the power the building needs. It's unlikely, right?
Right.
I did have quite a few more questions to ask, but in the interest of time, maybe I'll limit my next question to one before I move to audience. If we can keep the responses a little short to get to the questions.
Sure.
I kind of wanted to ask about the market development and the mass production of SMRs. So will domestic orders be enough to kickstart the initial manufacturing at scale? I know Andy mentioned significant international opportunities in the heavy industry sectors. If the domestic orders are not enough for the first manufacturing plants, will you need to look outside the country's borders, and how does that affect the US and Canada's I guess, competitiveness in where we're looking?
Well, I can tell you from the Canadian perspective, I mean, we're looking at both, right? We're looking at expanding. I mean, after the first one in Ontario, maybe there'll be more. Sask Power is looking at deploying similar technology, although they haven't announced which technology they're going with yet. So we do expect to have a Canadian fleet of the designs that are built here, but there's also been a lot of interest coming from markets around the world, and those markets are being developed at the same time, including, you know, plans to build the same designs in the US. And, you know, let's be clear, the designs that we're selecting they come from the US. This requires partnership, right? We're not saying that Canada is going to do everything. Of course not. The key is that there'll be a partnership between Canada and the US and possibly others to develop, hopefully, the supply chain to feed the market. But what I think is more important is that people need to work together to develop that market, right? So that, you know, I think the days of being a big supplier and saying, I'm comfortable waiting till the phone rings and someone tells me there's an order are gone. They're going to want to say, well, I'd like to help and help you develop the market because it's to my benefit. And I don't know if you can add to that, Andy.
Yeah, and I think therein lies an opportunity, going back to the theme of US-Korean cooperation. I mean, Korea, in some senses, is more active internationally, more aware internationally than a lot of the US outlook. Back to your original question, Brian, what we see in terms of partisanship, nuclear the last 5 years has been the most bipartisan issue in the US Congress. The Democrats for curbing emissions and the Republicans tend to like it for industrial development and national security. Whatever the motive is, you're getting votes in the Senate like 87-4 on nuclear. So I would submit that politically, we don't have an acceptance problem in the US. What we have is no emergency in the US. We're extending our fleet. We have cheap gas. There's no carbon tax. So it's the exact opposite situation of Europe. Europe will have to deploy fleets of SMRs, which is the main theme that Milt mentioned, to save their industry. And Korea is already moving on this, whether it's Hyundai, Samsung, Doosan bought Skoda back in 2009. So they have, you know, a metal bending, top quality firm in the heart of Europe as a partner. We can learn from partnerships like that. Going forward, what is very interesting to watch in Europe is not so much a partisan split, but a regional split. So you have Germany, Belgium, Italy against nuclear, but then you have Eastern Europe, France, Netherlands, the UK obviously is going to deploy, they say, 10 gigawatts over the next 15 years, where Eastern Europe doesn't want to buy gas and be dependent on Russia. Eastern Europe wants the high manufacturing, the heavy energy intensive industries, so that they can export and grow their economies, and they have to shift away from coal. So in Eastern Europe, they're going to buy fleets of SMRs in order to preserve their industrial base. They can't do it with wind and solar. It's a physical constraint. It's not about cost.
Yeah, that's a very, very strong point there, Andy. I want to move on to, we have about 5 minutes left, but I do want to move into the audience questions that we have not addressed yet.
Yeah, can I respond to my dear friend Cyril Draffin about third-party operators and licensing?
Yeah,
so,
coincidentally, that was the next question I was going to ask.
So yeah, Cyril brings up a very good point. So right now, I'm going to be controversial. I think that the NRC approach to licensing is hindering SMRs in the United States, requiring the vendors to come up with 90%, I think 50% would be more equitable, of the funding for the licensing is a major hurdle, hundreds of millions of dollars. I think that the slowness within which NRC is approaching SMRs will force people to go to Canada, to go to Europe for first deployments. And then the one company that we've seen in terms of third-party operators that Dr. Draffen raised is Exelon, is looking at UK and Europe. They've announced that publicly as a place to operate reactors. So I think the US as a partner brings operating excellence. I think that's an area where the US does excel. And I think that that kind of partnering effort in places like Europe, and then there was another question about developing countries. I think when you go to developing countries, SMRs are the only choice. None of them are really going to buy 1,000 megawatt units, and having an international third-party operator is essential for safety and sound management. So let me answer another question that way.
Thank you. We have another question from Rob Sweeney. The question is, you talked about land grabs for equivalent renewables. Many countries, including Korea, Japan, Netherlands, Belgium, etc., can't afford such land set aside. Plus, they do not have the mining, minerals, or manufacturing resources to make their goals. Isn't this an existential threat to the US and its allies, given just few countries control and dominate these resources?
I can just comment quickly on that, Brian. I think it's important. If people haven't seen it, the UN ECE, which is something about Europe in the title, although I know Canada's a member. But anyway, the UN ECE has published a life cycle analysis of various generation options very recently. You can Google it and find it. And the outcome is very interesting because it finds that not only does nuclear have the lowest life cycle carbon emissions compared to any technology, even less than solar and less than wind, that it also has the lowest land use and the lowest use of critical minerals. And these are all issues that are going to become important when we think about the environment. And then also there's a lot of political issues that go along with where critical minerals can be mined and all those things. But that's where, you know, all these sort of anti-folks that go, well, you know, does nuclear really produce less carbon because of the mining aspect or this aspect? Well, the study's been done. It was independent by the United Nations. It wasn't about nuclear. It was about generation in general. And it clearly shows that, you know, nuclear's credentials, environmental credentials. So I'd advise people to have a look at it if they can.
Yeah, that's fine. I'll have to take a look at that.
Yeah, those are good points. The one other point I would mention, Milt, on waste handling is the waste isolation pilot plant in New Mexico for the United States never, ever gets talked about because it's the DOE waste. It's not spent fuel. But the point is we've proven now since 1998, making 13,000 shipments of transuranic waste to a site in New Mexico, storing it 2,000 feet down. There's 90,000 cubic meters down there. The nuclear utilities never talk about it as a success story because they don't want to be linked to DOE waste. So it's a huge success story untold in America, but it demonstrates clear progress on subterranean shipping, subterranean storage, and the shipping, safe shipping across a vast area of the United States. Never talked about.
I see. We've come pretty much close to the end of the time limit. Maybe we'll have room for one last quick question. There is one question. If possible, could you please speak to the utility of new nuclear options for developing nations that are going to have new electricity needs far exceeding 1% per year?
I mean, I don't mind quickly answering that, Brian. I mean, definitely, as Andy already said, you know, SMRs are a good option for countries that are, you know, need generation, can't do big projects. They're just out of the realm of possibility. The challenge is they have to find a way as to how do you get ready in an economic way, right? You can't spend $2 billion to get ready for a $1 billion project, right? So that's where international collaboration is important. That's where, to be honest, that's where China and Russia are doing a good job going to these countries and helping them, right? And if we want to be in there competing, we have to do the same. So, but I would expect that there'll be very good options. You know, you look at many of the African nations, many of the Southeast Asian nations, they're all going to be starting to look at that. And I think there's a good opportunity for these.
Yeah, I'll just reiterate that it's going to be SMRs only, you know, in Africa and Latin America for the most part. It's going to be urban focused because that's really where they need the reliable electricity. And as they shift more toward electric transit, buses, not just cars, they can reduce their carbon footprint by deploying more nuclear. But, you know, as Milt highlighted, it's going to require international partnership and third-party operators in order to get that done.
Thank you. Well, we have reached the end of the time slot for this webinar. Milt and Andy, thank you so much for your time. I'm almost wondering if we have to bring you back for a part 2, given how much we still have yet to discuss. But thank you so much for your time, and thank you to all the Gabby attendees for attending this webinar.
Good to see you, my friend, Milt.
Yeah, you too, Andy. Thanks a lot. Bye-bye, everybody.
Goodbye.